fellow Toastmasters and honored guests. Today, I will be speaking on the human immune response. My goal today is to not be so technical that I bore you all to sleep, and also not be so oversimplified that you don't come away with some useful and interesting information. Your immune system is incredibly complex. At a high level, we can divide it into two broad categories. First is the innate immune system. And the innate immune system is something like a uniformed police officer. He's walking his beat at night and he sees someone in a parking lot. They're wearing a ski mask and carrying a Slim Jim. Now, the officer is immediately suspicious. He might approach the person, and certainly he'll move to arrest them if he sees them actually breaking into a car. The second part of your immune system is more like a police detective. She gathers evidence and information from a string of car thefts. She stakes out a parking lot and then arrests a car thief that she recognizes from previous surveillance camera video. In the first case, the officer hasn't ever seen that person before, but immediately reacts to something that looks suspicious. In the second case, the response takes a while to develop, and it only works for one thief that has struck before and left behind evidence. And that's your adaptive immune system. So let's take a look at what happens when you get an infection from a virus. Now, some of your cells go around your body looking for anything suspicious. And when they see it, they raise an alarm. This is called inflammation. It sends a signal to the other cells in your body and to your immune system to tell it that there's something foreign there. And it can recognize some obvious threats that fit a particular pattern. But it can get overwhelmed. It's a good first line of defense, and it can handle a small number of invaders. But if they start to reproduce, it can easily become overwhelmed. Normally, your cells are busy producing the things that your body needs to stay alive and healthy, using the instructions that it has in the nucleus that are like blueprints for making the various things that you need to stay alive. A virus can't reproduce on its own. Rather, it invades your cells. It gets into the nucleus and changes the blueprints so that it can start producing copies of itself using your cells. Eventually, those viruses get released and it destroys the cell. When the virus is inside your cell, your immune system can't really see it because it's hidden inside your cell wall. Fortunately, our cells have a way of displaying what's inside them and what they're producing by putting particles on its surface that let the other cells know what's inside. Some of your immune cells go around your body looking for those and reading those labels. And when they see a cell that's infected, they will move to destroy the cell. Either way, a healthy cell, a normal cell, gets destroyed, whether it's by your immune system or by the virus itself. What I've talked about so far is the innate immune system. And that is the immediate general response to something foreign inside your body. Let's switch over and look at the adaptive immune system. Where this picks up is by gathering pieces of the virus, the evidence left behind from infection. And it develops a profile of that virus and produces antibodies, which act like a target on its back. It sticks to the virus, sometimes disabling it, but certainly marking it so that other parts of your immune system can recognize it and immediately react. It's kind of like a criminal record keeping system where a criminal has mugshots and fingerprints taken, and they're entered into a database for future reference. In the case of your immune system, this process can take days or even weeks. So it's like a criminal record keeping system with a lot of administrative overhead. When you get a vaccine, it's like the FBI coming in and giving information to local authorities. You get a dead virus or pieces of a virus that help your immune system to identify that virus when it sees it. Again, producing antibodies that can help target that virus. mRNA vaccines work just slightly differently. In this case, rather than getting pieces of the virus, your cells get the instructions for making pieces of the virus. But because it's not changing the DNA in the nucleus, it's just getting an extra copy of the instructions that it throws away after it's done. It's not damaging the cell, and the cell isn't destroyed in the process. So there's less inflammation, and you don't feel as sick. It's that inflammation when your body is first reacting to that virus and that cell destruction. That's when your body starts to produce mucus and your temperature goes up and your blood vessels actually start to become leaky to help your immune cells get into the area of the infection. But if the cells aren't destroyed, you don't get as much of that inflammation, so you don't feel as sick. And there's not quite as much collateral damage of your cells getting destroyed. Here's some resources if you'd like to learn more about how your body reacts to viruses or how vaccines work. And I hope that I've been able to provide you today with some good information to help you make decisions about your health. Mr. Toastmaster.
Thank you for that, Dr. Ruth. Thank you. You know, I believe that Ruth has brought technology to a new level. I've never seen so much stickmen in action. Thank you. Thank you.